again, everyone. Welcome back to Intermediate Algebra for our next to last section. Today we're in section 10.4, and we're going to be talking about adding and subtracting radical expressions, and that is our only objective for today. So let's get started. So first, I want you to know that adding and subtracting radical expressions is very similar to combining like terms. It is exactly the same concept. Radical terms can be combined only if the radicands are the same. Remember, radicand is the thing under the radical. So radical terms can be combined only if the radicands are the same and the indexes are the same. And to combine radical terms, all we have to do is add or subtract their coefficients. Like I said, it's exactly the same as combining like terms. You just add or subtract the coefficients as required. And when you do that, the radicand and the index will stay the same. So here is an example for us. So let's take a look. It says add or subtract to simplify each radical expression. Here we have 4 square root of 2 plus 3 square root of 2. So of course you understand that this is 4 times square root of 2. So think of it as if it said 4x plus 3x. You wouldn't have any trouble adding 4 plus 3 and getting 7x. So it's the same thing here. 4 of these plus 3 of these gives us 7 of these. So 4 square root of 2 plus 3 square root of 2 is 7 square root of 2. Okay, then on part B, we have 2 square root of 3 minus 5 square root of 3. And again, the radicals are the same. They're both square root of 3. So all we have to do is combine coefficients. 2 minus 5 is negative 3. And so we end up with negative 3 square root of 3. Here on part C, the radicands are different. So we can't just say 3 plus 1 is 4. What we have to do first is simplify each radical. And then if the radicands are the same, we can proceed. So let's think of 24 as 4 times 6. And let's think of 54 as 9 times 6. So we'll just write it that way. 3 square root of 24 is 3 times the square root of 4 times 6, and square root of 54 is square root of 9 times 6. Now our next step is to apply our product rule for radicals. So we will split these two up into radical times radical. So we're going to have 3 times square root of 4 times square root of 6 plus square root of 9 times square root of 6. Now both of these square roots come out as whole numbers. So now square root of 4 is going to be 2, and square root of 9 is going to be 3. So that's going to give us 3 times 2 times the square root of 6 plus 3 times the square root of 6, because square root of 9 becomes 3. Okay, now 3 times 2 is 6. And now we have 6 square root of 6 plus 3 square root of 6. So you can see that the radicals are the same. And 6 plus 3 is 9. So we end up with 9 times the square root of 6. Okay, continuing example 1. The same thing has to happen on part D. The only difference here is that now we have an x under the radical. But that doesn't make any difference to how we approach the problem. So again, we can't do anything to this problem until the radicals are the same. So first let's simplify these. 20x we can think of as 4 times 5 times x, and 45x we can think of as 9 times 5 times x. So we'll write that out. And then we can use our product rule for radicals to separate these radicals. So we'll have 2 times the square root of 4 times the square root of 5x minus square root of 9 times the square root of 5x. Now we could separate the 5 and the x and put them each under their own radical, but since they can't be simplified anyway, there's no need to do that. So I just left them under their radical together. But the square root of 4 becomes 2, and the square root of 9 becomes 3. So that gives us 2 times the square root of 5x minus 3 times the square root of 5x. And of course 2 times 2 is 4. So now we have 4 square root of 5x minus 3 square root of 5x. And now the radicals are the same exactly. And so now we can combine coefficients and say 4 minus 3 is 1. So we get 1 square root of 5x, which is just written as square root of 5x. You don't even need the 1 in front. Here on part E we have 2 square root of 3 minus 4 square root of 5. Now these radicals are different, but unlike part C and part D, we cannot simplify these two radicals and make the radicands the same. So in this case, we would not be able to simplify this expression using radical notation. Now I need you to notice how adding and subtracting is different from multiplying. When we're multiplying radicals, we can write things like this. We can say square root of 3 times square root of 2 is square root of 6 because we just multiply together what's under both radicals. But addition and subtraction do not work that way. We can't say square root of 9 plus square root of 16 is square root of 25. We can't add the 9 and the 16 together because as we just saw, adding radicals means combining their coefficients and the radicals have to be the same. And we also can't go the other direction. If we have a sum under a radical, we can't split that up into two separate radicals. So don't get adding and subtracting confused with multiplication. Let's practice again. These examples work the same way, but we'll just see some higher indexes this time. So let's take a look here. We have 2 times the cube root of 16 minus 5 times the cube root of 54. Now these are cube roots, so under the radical we need to separate this into a perfect cube times whatever other factors are present. Now we know that 2 to the third power is 8, so we can write 16 as 8 times 2. And also we know that 3 to the third power is 27, so we can write 54 as 27 times 2. Let's see what that looks like. Now we can use our product rule for radicals to separate these into two radicals and these into two radicals. So that's going to give us 2 times the cube root of 8 times the cube root of 2 minus 5 times the cube root of 27 times the cube root of 2. And now the reason we did that is so that we could simplify these perfect cubes. So now let's go ahead and do that. So this is going to give us 2 times the cube root of 2 minus 5 times 3 times the cube root of 2. And so of course 2 times 2 is 4 and 5 times 3 is 15. And now notice that our radicals are the same. So now we can combine coefficients, and 4 minus 15 will make negative 11. So we get negative 11 times the cube root of 2 as our final result. Now looking at part B, we have 2 times the cube root of x squared y plus the cube root of 8x to the 5th y to the 4th. Now the indexes are the same, so that's good, but we will only be able to combine these two if we can make the radicands the same. So let's see what can be simplified here. So looking at this first radical, we have the cube root of x squared y. In order to simplify this, we would need a third power under the radical, but we do not have that. We have x to the second power and y to the first power. So this first radical cannot be simplified at all. The second radical has the third power of 2. 8 is the third power of 2. And then x to the 5th can be written as x to the 3rd times x squared, and y to the 4th can be written as y to the 3rd times y. And we do that so that we can see the third powers. Now let's go ahead and use our product rule for radicals on this second radical. We won't bother doing that with this first one because it can't be simplified. But here we're going to write cube root of 8 times cube root of x cubed, and then I went ahead and put cube root of y cubed here so that we had all the perfect cubes in front. And then the x squared and the y cannot be simplified, so I put them last under a radical together. And now cube root of 8 is 2, cube root of x to the 3rd is x, and cube root of y to the 3rd is y, and we have this little radical left over. But look what's happened. Now the radicals are the same. They have the same index and they have the same radicand. And so now we can combine these into one radical expression. But look at the coefficients. This coefficient is a 2 and this coefficient is a 2xy. So we can't add them together like we have done in previous examples, like over here where we had 4 minus 15 is negative 11. These two coefficients won't do that. But we are still going to write 2 plus 2xy, and then put that in parentheses and put the radical behind it. So that way we only have one radical in our final expression. Okay, now on part C, we have 5 square root of 4x to the third plus 3 cube root of 64x to the fourth. Now we can simplify both of these radicals, and we should do that, but we are not going to be able to combine these into one because this one is a square root and this one is a cube root. Let's go ahead and do what we can though. Of course, 4 is a perfect square, and we can write x to the third as x squared times x. On this cube root, we're looking for perfect third powers. So we'll have 3 times the cube root of 64, and we can write x to the third times x. Do you see why I did x to the third here? Because I needed a perfect third power under the radical. Over here, doing the square root, I needed a perfect square under the radical. Now let's use our product rule for radicals, again, to split these up into separate radicals. So we'll have 5 times the square root of 4 times the square root of x squared times the square root of x, plus 3 times the cube root of 64, which you know 64 is a perfect cube, so that's fine, and then times the cube root of x to the third times the cube root of x. And now we'll simplify each of these radicals that we can. So we'll have 5 times 2 times x times the square root of x, plus 3 times 4 times x times the cube root of x. Okay, now 5 times 2 is 10, so that's going to make 10x square root of x, and 3 times 4 is 12, so that's going to make 12x cube root of x. And now we have simplified each of these radicals, but this is as far as we can go because this one is a square root and this one is a cube root like we said earlier. So these two cannot be combined. And here is example 3. So this one says perform the indicated operations, assume that all variables represent positive real numbers. And we have here in part A 2 times the square root of 75 over 16 plus 4 times the square root of 8 over the square root of 32. So first what I want you to notice is that 75 over 16 cannot be reduced. And therefore it's in our best interest right here to split this up into 2 separate radicals and simplify them each separately. But on the second term, 8 over 32 could be reduced if these two numbers were under the same radical together. So I'm going to use the quotient rule 2 ways. I'm going to use it here to split these 2 radicals up, and I'm going to use it here to put these 2 radicals together. So it's going to look like this. 2 times the square root of 75 over square root of 16 plus 4 times the square root of 8 over 32. Now, back on this first term, 75 is 25 times 3. You know that from handling quarters. 3 quarters makes 75 cents. So the 75 will break down into 25 times 3. And, of course, square root of 16 is 4. 16 is a perfect square. Over here, on the second term, the 8 over 32 will reduce to 1 over 4 because both of these numbers can be divided by 8. Now, back on this first term, I'm going to use the product rule for radicals to split these 2 radicals up. But instead of writing square root of 25 times square root of 3, I'll go ahead and simplify this radical. So that's going to make 2 times 5 times the square root of 3. And in the bottom, we already have our 4. And over here on the second term, I'll use the quotient rule again to split this up into 2 radicals. So I'll have 4 times the square root of 1 over the square root of 4. And now we'll do one more step to multiply these 2 together and reduce both of these radicals. So 2 times 5 is 10. So now we have 10 square root of 3 over 4. And right here, the square root of 1 is 1 and the square root of 4 is 2. So we end up with 4 over 2. Okay, now all that's left to do is simplify these fractions. So notice here, 10 and 4 can both be divided by 2, so we'll do that. 10 divided by 2 is 5, and 4 divided by 2 is 2. And right here, 4 divided by 2 simplifies to just plain 2. And so this is our final answer for Part A. Part B is very similar. You might want to pause the video and try this one on your own, but I'm also going to go through it with you. So here, let's use the quotient rule to split this up into 2 radicals and put these two radicals together. So that's going to make 9 times the square root of 48 over square root of 25 minus 2 times the square root of 2 over 98. Now I wanted to do that again because this fraction cannot be reduced, so I may as well simplify each radical separately. But if this were one fraction under one radical, it could be reduced, so I did that. Now, we'll think of 48 as 16 times 3. You can think of it as 6 times 8, but that's just going to make you have extra steps. The biggest perfect square that goes into 48 is 16. So let's go ahead and write 9 times the square root of 16 times 3, because 48 is 16 times 3. And in the denominator, the square root of 25 is 5. On the second term, the 2 over 98 reduces to 1 over 49. And now we'll go ahead and simplify this radical using the product rule, and then we'll split this radical up into two separate radicals. So we'll have 9 times the square root of 16, which is 4, and then we have the square root of 3 here, and it's all over 5. The second term splits up into 2 times square root of 1 over square root of 49. And of course, all that's left to do now is multiply 9 times 4 to get 36, and then simplify the square root of 1 and the square root of 49 to get 2 over 7. So 2 times square root of 1 is 2, and the square root of 49 is 7. And now look what we have. We have simplified both radicals, and these fractions cannot be reduced. So there's really nothing more to do here, and this one is finished. And that's it for adding and subtracting radicals. I hope this was helpful to you, and good luck.